In this video, I'm going to explain the calculation of final draft when a weight is shifted. So let us consider this example where this is the vessel and this is the water line. For sake of simplicity, let us assume that the vessel is at even keel. That means the forward draft and aft draft is same, or the trim is zero, whether all the draft throughout is same. Trim is zero, and we consider this scenario. Now let us also consider that center of flotation is amidship. The center of flotation is the point about which the ship trims. Well, this is the geometrical center of a water plane area. Let me mark this water plane area. Well, if the ship is floating like this is the water plane area. This is going to be water plane area, and the geometrical center of this water plane area is a center of flotation. Since the center of flotation is amidship, the change in the forward draft is TF. So initially the draft was this. However, after shifting this weight, my draft is this one only. So TF is the change in the forward draft. Similarly, TA is the change in aft draft. So initially the aft draft was this, but now the draft is increased to this one. So TA is the change in aft draft. Since the center of flotation is amidship, the change in the draft forward, that is TF, and the change in the draft aft, TA, will be equally divided. So we can say that TA will be equal to TF. Now let us consider the scenario where the center of flotation is not amidship. So that means the center of flotation is not amidship, and this is very much possible because of the shape of the ship. The geometrical center or the geometrical water plane area could be different. So the geometrical center may not be exactly at amidship. So this center of flotation could be little bit displaced from amidship. Well, in this case, let us consider this triangle, this green triangle. And this is nothing but a TC. TC is the trim cost. So I can put it this way also. Initial trim was 0. Initial trim was 0. Ship was at even keel. But the final trim after shifting the weight, say final trim was T. So what is the total trim cost? So trim cost is 0 minus T, that is T only. I can write like this: TC. Trim cost is TC. So here this is the trim cost. So tan theta is TC divided by LBP, where this is the angle. Now similarly, let us consider another triangle. Say this was the F, center of flotation, and let us consider this is small triangle, and this distance is LCF. This distance is LCF. Well, this LCF means longitudinal center of flotation from aft perpendicular, and this is the TA, change in the draft aft, because of this TA is the change in the draft aft because of shifting. And again in this blue triangle we have this theta, and this triangle theta, tan theta, is TA divided by LCF. Well, this distance is LCF. Let me mark it again. This is LCF. So we have this relationship where TA divided by LCF is equal to TC divided by LBP, or simply TA is LCF divided by LBP into TC, and this is a pretty useful relationship here. We will also notice that total trim cost, that is TC, will be equal to TA plus a TF, that is the sum of the change in the trim aft and trim forward will be the total trim. We can verify this here from here also. This portion is TF and this is TA, and this total portion is TC. Okay, well, now let us proceed further. Say for example, this is a vessel A and this is the length. Say vessel is of 100 meter and this is the midship. And now the center of flotation is 2 meter forward. Let me just mark here with this color. So HF is 2 meter forward. So we can say AF or LCF is 50. This is 50. This is going to be 50 meter. And this plus 2 meter. So total distance of center of flotation from aft is going to be 52 meter. Now we also know that the ship pivots about this point, that is the center of a flotation. Vessel will pivot about this point. Okay, now let's have some draft. Say forward draft is, let me just mark, forward draft is 6 meter and aft draft is 8 meter. So we know the trim is the difference between forward draft and aft draft. So let me find this. The trim is a 2 meter by a stern. And let's have this weight here, W. Okay. Now I shift this W weight from aft to forward. After shifting this weight from aft to forward, there will be a trimming movement, and this trimming movement is W into D. So here let us assume this weight was W, which is 200 ton, and it is shifted to a distance of 60 meter. So we'll have the trimming moment 200 into 60 is equal to 12,000 ton meter by head. Why by head? Because I shifted this weight from aft to forward, so there will be a trimming moment in forward direction. And now we know that the trim cost can be calculated by trimming moment divided by MCTC, where as per the definition, MCTC is the moment to change the trim by 1 centimeter. So in this scenario, let's say the trimming moment is 12000 and let's say the MCTC is 200. So we have this 60 centimeter trim cost, and that will be by head. Now let us work out what is a trim aft. Change in the draft aft will be AF divided by L into TC. Well, we had found this formula that TA is LCF divided by LBP into trim cost. In the short form, instead of LCF, I am writing this AF, and instead of LBP, I am just writing AL and into TC. So, well, AF is 52 and L is 100 and the TC is 60. So this will give me, let me use the calculator to find out. 52 multiplied by 60 divided by 100, so this gives me 31.2. So this gives me 31.2 centimeter. And we also know that the formula of total trim cost is TC is equal to TA plus TF. So this relationship will give me TF, that is trim forward, is equal to TC minus TA. So let's find out the TC is 60 minus 31.2. I think I should use the calculator. 60 minus 31.2 is equal to 28.8. So here the forward draft was 6 meter and aft draft was 8 meter, and because of the shifting from aft to forward, we have some change in the trim. Total trim cost is 60 centimeter, which this 60 centimeter has been divided in two parts, which is TA and TF. So let me summarize how we write. Say initial draft is, say, let me put it here, forward and aft, and it is better to write in three places. So 6 meter like this, meter, and aft is 8 meter. Now change in the draft aft and change in the draft forward. So first let's write the forward one, which is 28.8 centimeter. So in meter is going to be 0.288. Similarly, this aft one is going to be 31.2, so we can write 0.312 meter. And we know that the vessel was the weight was shifted forward. So we have the trimming movement by head. Hence the forward draft will increase. Let me just add here, the forward draft will increase and aft draft will reduce. So the final draft will be 6.288 meter, and this one will be 8 minus 0.312. Then let me use the calci again. So here 8 minus 0.312 will give me 7.688 meter, and this is a good idea to have this draft in 3 places.